So here we're looking at transformations of other functions. So here's a bit of an extension on what we were doing before. So when given two functions and asked to find the transformation required, consider which transformation has been attempted. For a simple function, this is easy. So in this case, we're just thinking about how do we get from y equals x squared to y equals x squared plus 2? Well, it's definitely not that. All we're doing is translating it up to. So that's nice and easy. But sometimes we get more complicated ones where we don't have a basic function like y equals x squared, but we're given y equals x squared plus 2. It's already had a transformation from the basic function. And we want to get to this function here. And so we've got to consider what transformations are required to get from y equals x squared plus 2 to this new function. Well, we can start with the term that defines the function and the function shape. In this case, it's a quadratic, so we're going to start with the x squared term. And we're going to go from x squared to half x squared. So we can do this two ways. We can dilate this to x or dilate it to y. In this case, I've dilated it parallel to y. So I want to get from x squared to half x squared, I'm going to half the whole function, which we know is a dilation parallel to y. Now if we do that, we've got to take a half of the whole of x squared plus 2, which will give us half x squared plus 1, if we expand this out. Now this function here is not this function here. It's lower than it needs to be, so we're going to translate it up. So to do that, we're going to add 3 to the end of the function, because we know that's how we do a translation upwards. And we're starting at 1, and we need to get to 4, so we need to translate it 3 more. So this is our transformation, and now we're back to the function. Now we've arrived at the function that we want to get to. So we started here, we ended up there, and we describe this transformation as a dilation parallel to y by a factor of a half. That's this value here. And we translate it up by 3 units. That's this here. Okay, first one done. What happens if we want to dilate something parallel to x instead? So in this case, we might do that. We start with x squared. We want to get to quarter x squared. Remembering that when we square it, this half is going to get squared as well, and we're going to end up with a quarter. So if we want to get to dilate it horizontally, we need to consider that when we square it, whatever this value here is going to get squared too. So if we want to get from 1 to a quarter, and we want to know what value would be squared to get a quarter, that would be a half, and that's why I chose a half here. So we substitute in a half x into this equation, which I've done here. We square this part, which gives us this, and we get left with plus 2 on the end. Now, this is where we are after the first transformation. To get to here, we need to transform another 2 units up. So I'm going to add an extra 2 to my transformation statement. Y equals f of half x, which we did up here, plus another 2. So I take this function and I add 2 to it, and that gives us this. In fact, I can do that in 2 steps to make it a bit clearer. So I start with f of half x, which is that, and then I add 2 more to the end, which gets me to a half x squared plus 4 as required by this. So we dilate parallel to x by a factor of 2, which is wrong. It's actually by a factor of 4. No, I was right. I only made the classic mistake. I make my transformation statement from my transformation function here. So I dilate parallel to x by a factor of 2, that's this, and then I translate it 2 units up. Example 3. Y equals x squared plus 2 to y equals 4 take 2x squared. This has changed to a negative, indicating a reflection, but we're going to do the reflection second. We're going to first make sure that the dilation's done. and get this to a 2, so it has the same magnitude. Right, so y equals 2f of x. That will get us to 2x squared plus 4 by multiplying everything here by 2. Then we're going to do the reflection. That just changes the sign of everything in the previous statement, which gives us minus 4 take 2x squared. We're nearly here, but we've got this part here, which is too low, so we need that to go up. The easiest way to do that is to add 8 on the end of our transformation statement, which will move the function up 8 units. If we add 8 to negative 4, that'll get us 4 take 2x squared, which is the function that we were required at the beginning. So going back to this statement, what did we have to do? We dilated parallel to y by a factor of 2, we reflected across the x-axis, and we translated it up 8 units. And there is a simple-ish description of transforming other functions. Thank you, everyone.